Hello, in this video, I just want to share with you on how I understand by latent Dirichlet allocation. So for me, it's part of the natural language processing, so which means that we tell the computer how to carry out instructions and try to understand the natural languages. So which means that we tell the computer to deal with textual data. Examples of natural language processing are topic modeling, sentiment analysis, and text generation. So in this video, I'll be just looking at LDA. So for topic modeling, we have other algorithms that we can use to extract topics from documents. But here we'll be looking at this. But they are quite similar. Okay, they are quite similar. So what I mean by topic model is actually a type of statistical model to discover the different topics that occur in a different in a collection of documents. So which means that we don't have to manually read all the documents to figure out what are the topics, but instead the machine will tell us that the distribution of the topics within different documents. And that's not it. And of course, it also tells us for different topics, there is a distribution of words. And then we have latent Dirichlet allocation. So, for example, like we have, so this is a hierarchical Bayesian generative probabilistic model. So which means that we think that documents are presented by a mixture of latent topics, and these topics are actually characterized by a distribution over words. So what I mean by this is, let's look at this. So these are the words, for example, and these are the topics. So the topics is actually representing the word distribution. So you can see topic 3, these are the different percentages of different words within that topic. And of course, a good example would be this. So we can see for arts, okay, within this document, within this topic, so we have the word distribution. So we have actor that appeared in the arts 0.008 percentage, and then we have Z2, which is badges, and the percentage is very small. So we can see the machine will help us to see to figure out the word association and assign them to different clusters, and then we manually give the meaning to different clusters. Okay, that's what we do. And of course, that's definitely not the LDA, because LD assumes that one document will be presented by different topics. So probably like this. Okay, so this is one document. This is actually one customer review, but we treat this as a document. So we have different topics among here. And then for one document, we have different probability of different topics that within that document. So for example, topic 2, we have this as the percentage that appeared, the probability that appeared in this particular review. So basically, we have the percentages. So these are the frequency of the words that appeared in this topics. And you have to know that all the words, the bag of words that we have in the corpus, for example, like this, these will be summed up to 1. Okay, sum up to 1. So all the words will be presented by different topics. And of course, for different words here, the percentages for different topics will be summed up to 1. So these are the things that we need to know. So before we move on, I will be showing you, this is the notation plate notation. I think this is called plate notation. So basically, it means that we have these M stands for the number of documents, and then we have N. N is actually the number of words that within the document, and then we have W. W is the words, and then we have Z is actually the note. It notates each topic is assigned to each word, and so basically this is the documents and what we have. And then theta here is actually the topic distribution per document. Alright, so can you see here is within the document. And now we can see beta. Beta is actually the topic per document word distribution. So word distribution within that topic. So this is what I understand by LDA. So basically we'll be able to know the word distribution and topic distribution within a document.